All right, so today we have law of sines. I'm going to take that unit number off just, well, no, I'm not. Today we have law of sines. This very first statement is very important right there, that the law of sines will never give you an obtuse angle for an answer. Therefore, if you're trying to find an angle that either is or could possibly be obtuse, you cannot use law of sines. Now, obviously today that's all we're doing, so we're not going to make you do that. But starting tomorrow, sometimes there will be obtuse angles that are the first thing you have to find, and there's another law to find those. But again, law of sines cannot give you an obtuse angle for an answer because, remember, our restrictions, inverse sine will only give you an angle in either quadrant 1 or 4, and those would be acute angles. All right, so here is kind of the formula, we could call it, for a law of sines. You take the sine of an angle and divide by its side, the side that is across from it. And you set that equal to the sine of another angle and divide it by the side that's across from it. And that setup right there will give you an answer. Now you can't obviously have all three, but you could have those two set up. You could have these two set up equal to each other. Or you could have these two set up equal to each other. Any of those setups, a proportion, that's all it is, a proportion. You cross multiply, not multiply across, that's just multiplication. You cross multiply to solve for your missing angle or your missing side. And just like in Unit 3, if a side is missing, you're going to be given the angle. If an angle is missing, you have to use the inverse. So that's going to be very important to remember. What is also important to remember, we're dealing with triangles. So when we put this in our calculator, we need to be sure and be in the correct mode, which is going to be degree mode, or you're going to get a bunch of answers that don't make sense. So be sure you're in degree mode when you work these problems. All right. Very important that you read the problem and label correctly. Some people are still not labeling correctly, so be sure you do that. So here, I'm going to draw a triangle. Doesn't have to be to scale. You might want to make it kind of to scale, but not have to be perfect to scale. So, angle A is 110. Be sure you label that. This is triangle ABC. You should not have any letters other than ABC in your work. So, that's angle A. And then I'm just going to pick this one to be the 20-degree angle. Therefore, that leaves C right here, and then it tells us side C is 25. Very important that you label that triangle correctly. The side that's missing over here is B. The other side that's missing is A. Solve the triangle means find everything that is missing. So, the other thing that's missing in this is angle C. Angle C is easy to find. We don't even have to do any trick. We take 180, subtract that from 110 plus 20, and you have your missing angle, 50 degrees. So angle C is 50. Don't forget your degree symbol. All right, so there's one answer. Then we're looking for side A and side B. So we're going to use law of sines. We have to have two setups to find that. I do not have to see your setup for adding and subtracting. I do have to see your setup to find both side A and side B. Well, right here, the only angle and side that we have is side C and angle C. So I have to say sine of 50 degrees over its side, which is 25. And then I can pick A or B, doesn't matter which one we do first. Sine of, let's say, 20 degrees over its side, which is B. And then you solve for B. So you cross multiply, divide, and you get your answer of 11.162. So, just for an example, in my calculator, I would do 25 times the sine of 20 equals, and then divide that by the sine of 50, and that should give me my answer right there. Okay? We don't have any units, so you can put a U if you want. Me, Miss John, personally, I do not mind if you don't. If you do, that's fine, but be sure you do what your teacher wants. So there's one side. This is not a right triangle, so we can't say a squared plus b squared equals c squared, so we have to have another setup. Your other setup would still say sine of an angle over its side. And then we would say we're going to solve for a, so sine of 110 over a. Now, some of you might think, you just told me you can't find, law of sines won't give you an obtuse angle. And that's true. I'm not looking for an angle. I'm looking for a side. I can put an obtuse angle in there, okay, because that goes back to unit 1. That's not finding the inverse. You can take the sine of an angle, it equals a side, or just a number. The inverse of an angle of a side equals an angle. So again, I can use an obtuse angle, I just can't get an obtuse angle. So again, 25 times sine of 110, divide that by sine of 50, and you get your side A to equal 30.667. Be sure you are practicing putting those into the calculator. I'll do that one again for you right over here. 25 times the sine of 110 equals divided by sine of 50. There's your answer. Be sure that your answer makes sense. The side across from 110 should be the biggest side. So 110 is obviously the biggest angle. So side A should be the biggest, which is 30. Side B is a 20-degree angle. Side C is a 50-degree angle. So notice that everything matches up. The biggest angle matches with the biggest side. Smallest angle, smallest side. In between angle, in between side. Okay, so we have just solved the triangle. It gave us 3 parts. We had to find 3 parts. Alright, so here we have a 45 and a 60-degree angle. Now this doesn't necessarily mean we can do the whole thing without a calculator, because yes, we know 45 and yes, we know 60, but we're not going to know the other angle without a calculator. So let's just go ahead and draw a triangle. So I'm just going to call this angle A, 45 degrees. And I know side A, so I'm going to go ahead and label that 14. Then I can pick whichever one I want to be B. Be sure you label it appropriately. Side across is side B. And then here's C, so side across is side C. So again, add those two numbers up, subtract from 180. That will get you angle C is 75 degrees. So there's the first thing. You do not have to use any kind of law of sines because 2 of the angles are given. If 2 angles weren't given, then that's what we need to do. All right, so now we have our setups to find the other angles. And if you want to label this on your triangle, that's fine. Might make it a little bit easier. All right, so we have to first use the angle and the side that we know. So sine of 45 over 14. That's going to be in both of our equations because that's the only combo that we know right now. Then we can say sine of 60 degrees over its side, which is B. 14 times sine of 60 divided by sine of 45. If we did that in our calculator, which again, this could be calculator or non-calculator, we get 17.146. Okay, if that we were only looking for that particular angle, this could be a non-calculator problem. So let's just say we only asked for side B, and this was on a non-calculator section. So sine of 45 is root 2 over 2, 14. What is sine of 60? You go back to your unit circle, you look, and you see that's root 3 over 2. So root 3 over 2 over B. And then we cross multiply and solve this problem. So we get root 2 over 2b equals 14 times root 3 over 2. So that's root 2 over 2b equals 7 root 3. We've got to get rid of a fraction, so we could divide, but I'd rather multiply by the reciprocal because that's what we're going to have to do anyway. Those cancel to be 1. And b equals 14 root 3 over root 2. If you want to rationalize, you can rationalize. Okay? You can multiply by root 2 and get 14 root 6 over 2, which simplifies to 7 root 6. Okay, so that is a possibility of being able to do that one without a calculator. It just, if it's on a calculator section, use your calculator. If it's not, then you can do that one very easily. Now, to find side C, we can't do that. Sine of 45 degrees over 14 equals sine of 75 degrees over its side, which is C. Even though we know what the sine of 45 degrees is, we do not know what the sine of 75 degrees is. Eventually, we'll learn how to do that without a calculator, but not yet. So this would be a calculator problem. 14 times sine of 75 degrees, divide by sine of 45 degrees, and you get 19.124. Very important that you label your answers. Answers must be labeled, and or on a test or quiz, if we have blanks for you, you must put them in the correct blank. Be sure they are in the correct blank. All right, here a civil engineer wants to determine the distances from point A, B, C. So it tells us that A to B is 20. It tells us that A is 110 degrees and B is 25 degrees. So once again, we can figure out what the other angle is just by adding and subtracting. We get 45 degrees. So C over here is 45 degrees. Now, we need that information in order to solve this problem, but in order to answer the question, that isn't an answer that I would provide because it doesn't ask me that question. It says find AC and BC. So if we are labeling this like we have been before, and this is C, I'm going to say that AC is equal to B, and I'm going to find that answer. And I'm going to say that BC is equal to A, and I'm going to find that answer. So you have to find two answers. I have relabeled AC and BC just using a single variable, just because I think that's easy. As long as you state that, it's okay to do that. If you don't state it, then I have no idea what you're looking for. All right, so I have to say sine of 45 degrees over 20. That's one thing I have to use. And then I can pick whichever one I want to solve for first. So let's say sine of 110 over A. Again, cross multiply. 20 times sine of 110 degrees. Be sure you're in degree mode. Divided by sine of 45 degrees will give you A, which is 26.579. And we have a unit, so we need to be sure and put meters. So there is one answer. Then my other answer, which is a setup. Here's the setup for this one. So my other setup would be sine of 45 degrees over 20 equals sine of 25 degrees over its side, which is B. 20 times sine of 25 divided by sine of 45 is equal to 11.953. And that is meters. Don't forget your units. No need to get a point taken off every time you forget a units. If there are units, be sure you put that. So again, does that make sense that A is the biggest? Yes, because angle A is the biggest. Does it make sense that B is the smallest? Yes, because angle B is the smallest angle. All right, so here's one a little bit different. It gives us three sides and only one angle, so 31 degrees, which is angle B. So that means this is side B. If we say this is angle A, then this is 28. And if we say this is angle C, then this is 18. Now, this is where that first statement, law of sines, will not give you an obtuse angle is very important. All you have to do is be sure you don't find the biggest angle first. So, because the angles are missing, I'm going to have to use my inverses now. And I don't want to find angle A first because angle A might be obtuse. We don't know. Might not be. But if it ever has a possibility of being obtuse, meaning it's the angle across from the biggest side, then we don't want to find that angle first using law of sines. We do have something called law of cosines, which we'll learn tomorrow. But for right now, we don't have enough information to do that. So we want to find angle C first because we are 100% sure that angle C is not going to be obtuse, because an obtuse angle is bigger than 90. You can't have two angles that are bigger than 90 in the same triangle, or there is no triangle. So I want to use sine of 31 degrees over 15. I must, if I want to get the right answer, find angle C first. Sine of C over 18. Now this one's going to be a little bit different work because we're going to have to use the inverse. So you cross multiply. So we get 15 sine C equals 18 times sine of 31 degrees. Divide by 15. And we get sine of C equals that number. So let's go ahead and find that number. 18 times sine of 31 equals, and divide that by 15. So we get 0.61 and so forth. Now, we have to take the inverse of that 0.6 number, and that will give us the angle. So we take the inverse of that 0.6 number, the whole thing, not the rounded answer, and you get your angle. So you have your angle C is equal to 38.174 degrees. How do I find my other angle? Well, I know one angle's 31, so I just add that to 31. There's two angles. 180 minus that 69 degrees is my other angle. So angle A is equal to 110.826 degrees. Notice it is obtuse, so if you'd use law of sines, you might get an extraneous answer, you might get a negative answer, but it would be incorrect. So very important on this last one that you must solve for angle C first, and then just add the two. And then if you want to, later on when we learn law of cosines, you could find that angle. But once you have two, the best thing to do is to add the two together and subtract from 180 so that you can get the correct answer.